In the previous course, we have learned that spectrum is an important resource for wireless communications. That is one of the most important factors affecting the data rate over the air interface. To improve the air interface rate for 5G, we need lots of spectrum. In the future, 5G spectrum will have to rely on extremely high frequency spectrum. The 5G spectrum resources defined in the Frozen 3GPP Release 15 protocol can be divided into two frequency ranges, FR1 and FR2. FR1 is the band from 450 MHz to 6000 MHz. We call it the sub-6 GHz band, or also sometimes the low frequency band. It's the main band used by 5G. The frequencies below 3 GHz are called sub-3 GHz, and all remaining spectrum is referred to as C-band spectrum. FR2 is the millimeter wave spectrum. It's a high-frequency band. The FR2 spectrum for 5G bandwidth expansion. There's a lot of spectrum available in the FR2 range. The frequency resources on FR1 and FR2 are different, so 3GPP specifications stipulate different carrier bandwidths for the different frequency bands. You can see here that the smallest amount of carrier bandwidth allocated to any sub-6 GHz band is 5 MHz, and the largest is 100 MHz. For the millimeter wave spectrum, in contrast, bandwidth ranges from 50 MHz all the way up to 400 MHz. When 3GPP Release 16 comes out sometime in the future, there may even be an 800 MHz carrier bandwidth available. We have also learned that there will not be 1.4 MHz or 3 MHz bandwidths, mainly because one of the main selling points of 5G is going to be a wide bandwidth. And there are already 5 MHz, 10 MHz, 15 MHz and 20 MHz LTE carrier bandwidths reserved for 5G. Now, let's take a look at how 5G spectrum is being allocated around the world, including the sub-6 GHz and millimeter wave bands, and which specific frequency bands are being allocated to 5G. So, in the illustration here, we can see how the two spectrums, sub-6 GHz and millimeter wave, are allocated. The sub-6 GHz spectrum is mainly concentrated on 3 to 6 GHz C-band spectrum. There's a 3.3 to 3.6 GHz and a 4.8 to 5 GHz, with a total of 500 MHz of spectrum altogether. For the millimeter wave spectrum, there's 24.75 to 27.5 GHz and 37 to 42.5 GHz, for a total of 8.25 GHz of bandwidth. Other countries have allocated spectrum in a similar way. For the most part, there's plenty of millimeter wave spectrum to go around, but not so much on the C-band. There may be, however, the C-band spectrum resources of the continuous 200 MHz available down the line, and that spectrum may end up becoming the main frequency band for 5G. Just now, we learned about how 5G spectrum is allocated, especially about how C-band and millimeter wave spectrum is allocated in China. We have also had to think about how, if and when today's 2G, 3G and 4G networks are deprecated. The sub-3G spectrum that is freed up can be used to deploy 5G. In the future, we will have sub-3 GHz, C-band and millimeter wave resources available to deploy 5G networks. But this does raise an important question. When we deploy 5G networks, will we have to deploy all three spectrums across the entire network? As we all know, the higher the frequency, the shorter the range. The lower the frequency, the better the coverage. So millimeter wave will be used mainly for traffic hotspots like railway stations and airports. C-band deployment will mostly focus on urban areas based on the coverage and capacity it provides compared to millimeter and sub-3G spectrum. And finally, we have the sub-3G spectrum. This is the lowest frequency range of the three, so it provides the best coverage. This spectrum will be used to provide the wide-ranging coverage needed for suburban and rural areas. Now, let's look at what sort of strategy will be used for 5G spectrum deployment. Let's take a look at some of the advantages and disadvantages of sub-3G, C-band and millimeter wave spectrums. What our deployment strategies will be in the future. Most of the sub-3 spectrum is currently already being used for 2G, 3G and 4G. So, for the moment, it is not under consideration for 5G deployment. In the future, as these 2G, 3G, 4G networks are retired, we can start refarming this idle spectrum for sub-3 GHz 5G deployment. The C-band represents some relatively new spectrum for 5G. It provides 200 MHz of continuous spectrum and with much better coverage than what millimeter wave spectrum can provide. C-band has advantages in terms of both coverage and capacity that make it a very important spectrum for the early stages of 5G deployment. And that brings us the third and final frequency range, the millimeter wave spectrum. There is more spectrum available in the millimeter wave spectrum than in the other two frequency ranges, but it is also the highest frequency spectrum, so the coverage is the worst. It is not very good at providing wide-range coverage. Millimeter wave spectrum will be used mainly for high-traffic scenarios. The range may be poor, but the capacity is excellent. This lesson has introduced 5G spectrum planning and the strategies used for future deployment. The spectrum resources of the different frequency ranges will be used for different types of scenarios. Sub-3G has the best range, so it will be used mainly for covering suburban and rural areas. C-band spectrum will be used mainly for covering large urban areas, and the millimeter wave spectrum will be used mainly for adding extra capacity at traffic hotspots.